All right, guys, welcome to chapter 2. We're going to cover section A today. At the very beginning of the section, the book refers to this thing known as the Large Hadron Collider, the LHC. That is a really phenomenal work of engineering in, what country? Sweden? Switzerland? Switzerland. And it's this giant tube of magnets. It runs like 17 kilometers around. It's huge. And what they do is they launch particles of matter at each other close to the speed of light, and they get these particles to crash into each other because it causes them to break apart, and then they can study the parts of atoms that way. They're using it in an attempt to figure out what happened at the moment of the Big Bang, which is what scientists theorize was the event that caused the universe to come into existence. I find it interesting that even in the year 2020, scientists have this equipment that's just phenomenal, and they still can't get to that point of origin. They still can't figure out what happened. As Christians, we know that God said, let there be light, let there be matter, and he created things with his words. The LHC is probably not going to show that, though. Those two theories that both require faith. Anyway, let's talk about matter. Matter is anything that occupies space and has mass. You have mass and you have volume, you take up space, therefore you matter. Jokes. A couple more vocab pieces for you. Pure substance is something that's just made up of one type of particle. We're kind of getting into chemistry now. I could have a pure substance of water. It's made up of just water molecules. I could have a pure substance of iron or sodium, things like that. A chicken nugget is not a pure substance. It's made up of too many different things, okay? That's a mixture. A mixture is a combination of two or more substances, okay? The three main states of matter there are solids, liquids, and gases. We'll talk about these a lot more in 8th grade. Today's lecture, and actually a lot of chapter 2, is kind of an overview of 8th grade science, which will go much more in detail, much more in depth when you guys get to 8th grade, okay? So, solids, liquids, and gases, you can kind of see them up there. Solids are tightly packed, liquids are a little farther spaced, and then the particles of gas are the freest to move about and the loosest, okay? Now this diagram shows you all the changes in state. I'm going to change one of them here. Whoops. Let me get my pen first. There we go. I'm going to cross out boiling, and I'm going to write vaporization. Well, I'm going to try to write it. You'll see it on the next screen if you can't read it there. Vaporization, okay? So let me go through this real quick. The next screen, you'll have an opportunity to pause it and write down these definitions, okay? Basically, when a solid turns into a liquid, that's melting. It makes sense. If you have an ice cube, it's solid, it melts, turns into a liquid, okay? The reverse is true. A liquid turning back into a solid, that's known as freezing. A liquid turning into a gas, that's vaporization, okay? A gas turning into a liquid is condensation. When it's cold and you can see your breath, that is condensation. If you can see it, like the steam over a pot of boiling water, if you can see it, it is actually a liquid, okay? The gas form of water is invisible. But then we've got these two other ones on the outside here. You can actually go directly from a solid to a gas without going through liquid first. That's known as sublimation. If you've ever seen dry ice, you've seen sublimation. So dry ice is solid carbon dioxide. It doesn't melt. It goes directly back into its gaseous form, and so that's sublimation. And then going directly from a gas to a solid, also skipping that liquid phase, is known as deposition. And that actually happens up in the atmosphere in some clouds. It's cold enough up there that the water vapor, it doesn't condense into liquid first, it just automatically freezes directly into ice crystals, okay? Okay, so this is the page that you can pause and get these notes down. I really want to talk about this little section right here, okay? So vaporization, again, is the liquid turning into a gas, but there's two examples of it. We've got boiling and evaporation, okay? Boiling has to reach a certain temperature before it occurs. water isn't going to boil unless it reaches 100 degrees Celsius. When that does happen, you can see that bubbles form all throughout the liquid, okay? Those bubbles in a boiling pot of water are filled with water vapor, okay? That's boiling. Evaporation is also a liquid turning to a gas. It's also an example of vaporization, but it's only happening on the surface. It's not happening down in the substance at all, okay? And it happens at any temperature. It happens faster when it's hotter, but it happens at any temperature. And what's happening is these liquid molecules of water are spreading out, okay? They're free on the surface, just like escape. They're like, hey, I'm gonna go play with my water vapor friends here. See ya. And it evaporates. That's why if you leave a cup of water out for a couple days, it actually gets lower, okay? Both of those are examples of vaporization. The rest we've already talked about. You can pause and get the words into your notes if you would like, okay? There are certain things that we can measure with matter. It talked about needing to have mass and volume. We can measure both of those things. The mass of an object is just the amount of matter in that object, and it's the same no matter what. Okay, your weight, which we're more commonly, used to talking about, is a measure of gravity. Since we don't go anywhere but Earth, we use weight and mass interchangeably. Okay, but when you step on a scale, the Earth's gravity is pulling you down, and so that scale is actually measuring your weight. It's measuring how hard the gravity is pulling down on you. Now, your weight can vary depending on where you are. If you go to the moon, there's less gravity on the moon, so your weight will actually be less. If you're in a pool and stand on a scale, because of the buoyant force of water, water actually fights against gravity. You will weigh less on that scale. That's why you can do chicken fights. That's why you can carry somebody around in the pool when you can't on the ground. Now, the mass does not change. A person's mass will be the same on Earth or on the moon, okay? It's a different measurement. Again, we use both of them interchangeably when we're still on Earth. And then that leaves volume. Volume is just the amount of space something takes up. Capacity is another word. It's more of a three-dimensional measurement there, okay? I think that's all. It is. All right, talk to you guys later.